Okay, so let's start with our in continuation with our discussion of how to develop code. So it all begins with writing these steps, logical steps uh, in the sequence that you would take to solve any given problem. Obviously, uh, it is understood that you know how to solve the problem. Only when you know how to solve the problem can you instruct computer to solve the problem, right? So, knowing how to solve a problem, then you would execute a certain number of steps in a particular order. So, the idea is starting from the input information, whatever is information that is given to you, how are you going to process that information, what kind of transformations are to be uh, applied on that input data, write it down in a sequential fashion, one after the other, and then that forms what we call as pseudocode. And it becomes much easier once you write it down in a sequence of action steps. It becomes much easier to figure out how the complete design of the program would look like. And you would be able to translate it in using the grammar of any particular programming language, whichever programming language you may prefer. So pseudocode is independent of any specific programming language. It is just the statement of tasks to be done in a particular order. And once you know what is to be done, translation to individual instruction or individual expression using a particular programming language is a straightforward exercise, right? And as we mentioned, there are only three requirements in order to write a working program. You only need three things. One is instruction flow of instruction. Computer should know what to do, what in which order, right? So that is given to you by the standard of the language. That flow of instruction will be top down. So it will start from the first sentence, first expression of master function, that is main, and then the flow will fall through one after the other. So it would be top down approach. So flow of instruction is settled. Then you need decision structures. Different statements, different expressions would need to be executed for certain cases, and different set of instructions would need to be executed for certain other conditions, right? That may crop up during the process of solution. So for that you need decision structures, and it provides, I mean, C++ provides you three decision structures. Uh, Four actually, if we include that ternary operator, that is a operator, it is not a decision structure, but essentially it is a very compact representation of if and else condition, right? So this conditional operator is essentially an if else condition. So if this expression is true, then execute this branch, and if it is false, then execute this branch, right? So it is essentially if or else, if and else construct, but written in a more concise manner. So if there is only one condition and you only need to take a call, you need to execute certain number of certain expressions only if certain condition is true. Only if some test evaluates to true, then execute this. Otherwise, these statements will not be executed at all. The control will just fall through the next line, right? If this condition evaluates to false, then these will be ignored and the control will fall through the next line in the code, right? And if you have a branching out, if some condition is true, then execute these statements, or if this condition evaluates to a falsehood, then take some other steps, right? So that is if and else. Now this can be applied in cascade, and you can have several branches of decision structure that you can have. So that several multiple branches can also be evaluated using switch statement, right? So you have this expression, and depending on various possibilities of this expression, you enumerate or you list out different set of executions that need to be executed. But then everything should follow by every case should follow by the last sentence has to be break. Break implies that control should pass out of this structure to the next line of the code. If you don't use this break, it will follow through the rest of the lines, right? And that may not be what you would have intended. Yeah. So sorry about that. So break is a very important detail that you need to consider, which is not there in any of the other things because there is no possibility of control passing through, falling through other branches. But in switch, control will fall through, right? So if this statement starts executing and if you don't have break, it will fall through the other conditions as well. The next statements would be executed. देखिए अगर कुछ एक्सप्रेशन लिया, let's say x is greater than y, right? And if the case one is some constant, let's say true, if this x, one identifier x is greater than y, it evaluates to truth, case true, it will execute this, right? Case 2 would obviously be false, and then this some other statement would be executed, right? You would list out something that has to be done in the case of false, right? But if you do not have this break, then first this sentence statement would be executed and then this statement would be executed. This is only a label, this is not a condition, right? This is only a label to which control passes. After that, there is no restriction. So this statement would be executed. If there is no break, then this statement will also be executed, right? And if there is no break, then this default statement will also be executed. This default is kept if none of these conditions, listed out conditions, arises, right? For example, if x happens to be equal to y, That is not considered, that is not covered under either true or false, right? So that is the default condition. So that will also be executed, right? So finally, compiler would not complain, program would execute, but your results would not be what you expect logically. Logically, when you analyze the situation, you find that x is greater than y. This sentence should have been executed. This you would not bother about checking these two, right? But what the fact of the matter is, these are only labels. This is where the control will pass. After that, it is again top down, right? Default does if you have these two listed outcomes, right? So if this expression, then what is the result of this expression? So you list out certain discrete possibilities that this expression will evaluate to this, right? And then if this expression evaluates to some constant value, then execute this. If this expression evaluates to this, it evaluates this. If none of these is met, then what to do? Right? Sometimes it may not be possible to think of all the possibilities that that expression may actually take the value. Right? So at least you should have a default segment which, if none of these is met, then at least it should be able to flag the matter that none of these conditions that have been listed out in switch, those have been satisfied, right? Or there may be some default action that might need to be taken. Yes, that's right. That is what I said. It is only label indicating to which point the control should pass. So if it is false, then it will go to false and then it will fall through, right? And if you have break, then after execution of these sentences, it would expressions, it would just break out of this entire loop, entire structure, right? Not nothing else will be executed. It control will pass through to the next executable statement in the code outside the switch, right? So this conditional operator, that is the only ternary operator in C++. Ternary operator uh, means it has three arguments. Binary operator takes two arguments, unary operator takes one argument. So this is the only ternary operator where you have expression and then two results. So whatever the condition of this expression happens, right? So if it is true, then you have, नहीं ये तो टेस्ट आउट कंडीशन है ना, दिस इज टेस्टिंग आउट कंडीशन decision, right? So if x is greater than y, if this evaluates to true, then take this value, result 1. If false, it evaluates to false, then return this. Right? So that is the basic ternary operator. So that is what I said. It is a very compact representation of if-else condition. If this condition is true, do this. If this is false, then do this. Right? So if it is a very small expression that you need to do, then ternary operator is a very compact way of uh, writing it down. But it does not add anything new. It is not something that cannot be done by using if statement or if else statement. For that matter, even switch is not necessary. Whatever you can achieve by switch can always be achieved by ordinary, I mean, this basic if statement or even if else statement. Then next is your repetition control structure. you need to repeat certain number of expressions certain number of times, right? So there are three repetition structures in C++ language standard. One is while statement. So if this expression is true, this set of statements would be executed as long as this expression evaluates to true. Right? So it's up to you how do you design or how do you construct this expression, right? So some kind of again it has to evaluate either true or false. And if another thing in C and C++, false is internal representation is integer value of 0. 0 indicates false and any non-zero value is treated as true. So it can be any integer expression also, right? So if that integer expression evaluates to non-zero value, that will be treated as true, and this will expression will be these statements will be executed. If that integer expression evaluates to 0, it will be omitted. Then you have do while. Again similar thing, except the difference is even if this expression is false, this set of statements will be executed at least once. There will be at least one pass because the condition is being tested after that. So control flow is from top to bottom. So this statement do, this statement will be executed, this statement will be executed, and then the expression will be tested. If the expression evaluates true, it will again go on repeating this until this expression here while testing turns to be false. And if this is false to begin with, then it will be only one run through these statements and then the control will pass through to the next line of the code. That is a minor difference between while loop and do while loop. While loop will not execute if the expression evaluates to falsehood. Do while loop, at least once execution, all the statements will be executed at least once. And if the for while condition evaluates to falsehood, control will pass through to the next line of the code. Then we have this workhorse for loop where we can have initialization, what should be the starting value of the loop index, and then what should be the terminating value of the loop index condition until when, and then what should be the increment of this index variable, how it should be incremented. So normally most common increment is of course 1, and that is how we use uh, increment operator I++, but you can actually use any increment whatever is required, right? Pardon? That's the syntax. That is the operator, right? I mean, you cannot question, you cannot ask me why my name is Manish. I mean, ask my parents. I didn't know, I didn't name myself Manish. Okay, so it's like that. That is equality operator. You are testing the equality. Single equal is assignment. These two things are different, right? So I plus plus, I minus minus, these are increment and decrement operator. Increment by unity, decrement by unity, right? And that is the way it is defined in the language. So just have to live with it. Can't do anything. So that is how the basic control flows in the code. but sometimes you may need to interrupt the control flow. You may need to take the exit after some condition is met, right? So it is possible to do so, and there are several ways of doing that. One, we have already seen the break statement, which jumps out of the whatever uh, control structure it is in, if structure or switch or even for or while or do while, it will immediately come out of it and go to the next line of the code after that structure, right? Whatever is the statement following that structure, control will be passed on to that. Continue is very interesting statement in which you would bypass or you would skip through rest of the statements in that structure for the current pass, but you would remain in the same structure. You would go back to the top, increment or change whatever needs to change, and then again go through, right? So that is quite often required if you wish to avoid taking certain steps for some conditions, but you still want to keep on repeating the statements that you are executing. So in that case, continue is the statement that would serve the purpose, right? So terminate a repetition control structure prematurely if required. C++ standard provides two different ways to achieve this. Break uh, terminates the repetition loop immediately and control passes to the next immediately next statement in the code. Continue statement skips rest of the loop in the current cycle and then goes back to the top of the loop, first statement in the loop itself with new value of the index, whatever. Control can also be transferred with goto statement. That's a legacy of past. You should never use goto, and therefore I will not describe how to use goto. Goto makes programs unreadable, not encryption. Control, you can actually ask control from first line to go to 100th line. From 100th line, you can go to 10th line. From 10th line, you can go to 78th line, anywhere. And then if you try to figure out what is the logic, you cannot figure out. It gets so muddy, right? But it's a very powerful tool. So you should be aware that you have, if everything else fails, you can always resort to go to. But it's like a Brahmastra not to be used. It is a because it makes understanding logic of the code very difficult. I mean, if you keep on running this cross country, I mean, top of the code to end of the code, then middle of the code, then somewhere else, you how do you keep track of what is happening in the code? It does it does not encourage disciplined programming, right? So go to, huh? Of course there will be. You seem to be very very destructive. Disruptor is the right way. Disruptor is now a positive word. It used to be a negative word earlier. So exit function can also be used for immediate termination or immediate exit from the code, complete code. But then this does the same thing as return, but return is a more decent way. It is like saying when you use the return statement, it does the proper uh, handshaking and saying goodbye and all basic housekeeping and cleaning up. Exit would just abruptly shut the door on your face, right? Not a nice thing to do. But again, these two commands, go to and exit, they are available as options of last resort. If everything else fails, this can be considered to salvage the situation. But typically, you can write a very decent code without ever needing to use them. So do not use them. Then, once we have discussed the basic programming, basic structure, now it comes the aesthetic part of it. Uh, my colleagues in architecture, they actually abuse me for saying that. I mean, architecture is all about aesthetics. They say it is not all about aesthetics. Aesthetics is only one small component of it, but I, I only see the aesthetics. So, matters of formatting is how to present things. Right? Obviously, aesthetics is one part of presentation. So, formatting, how do we manipulate the width of field? So far, we have been using unformatted input output, right? Just whatever is coming in the stream, extract it, whatever we are getting, and we insert in the stream without any format specification. But if you wish to specify certain specification that this is how it has to be treated or it has to be displayed, then there is a set of specifications for that, and that is contained in IO manip header library, right? And that library is accessible by using IO manip header files. So IO manip, so you can see here, IO stream allows you to use basic input output streams, and IO manip allows you to use the manipulation formatting uh, syntax, formatting commands, right? cstdlib is certain library functions. So set w, then constant, argument is constant. Set w is this, it stands for set width. So you are trying to set a fixed width. Whatever value is to be printed, it has to be set in these many columns, right? And then set precision, how many decimal digits need to be displayed. So if you want to retain 3 digits of precision, then you would specify set precision 3, and result would be indicated as 3.14 if you print pi. If you say set precision 4, result would be printed as 3.14. What will happen? What will be the next digit? Set precision, set precision 4, and you are printing pi. The value is 3.1415, right? So if you are setting the precision of 4, so 4 digits will be printed. So 3, then 1, 4, then you have 1. 1 will be rounded off to 2, right? It is 5, so 5, so number will be rounded off to even. So it will be printed as 3.142, right? So that's how it will work. So that's formatting. How do you want to present your results? And then fixed, it will impose the fixed form of numbers. For example, I want to write it as 3.14159. It will be printed as 3.14159. Otherwise, it would be default would be 3.14 multiplied by e raised to the power 0. Scientific notation. That is the standard way uh, float real numbers are displayed. Right? So if you want to suppress that scientific notation, you want the fixed format notation, then this fixed has to go. For example, if I wish to print 3.14159 is not the right example, maybe pi by 10 if I want to print, then if I don't say fixed, then it would be printed as 3.1415 multiplied by or e minus 1. That is the way it would be printed. If I wish to make it specific that I want it in complete fixed form of decimal representation, then that fixed format specification will enforce it to be printed as 0.31415, right? So that's the basic some play with the format and random number generation, just to give you an idea how do you generate random numbers using computers. So random number generator is available after the inclusion of CSTD loop. So you need to include C standard library to get access to this random number function rand. And this is what I say uh, type conversion. This rand function will generate random integer numbers from 0 to the largest integer that machine can store. Right? But it will be pseudo random number. It can be anything. So if you want to use uniformly distributed, and these are uniformly distributed numbers between 0 to the largest integer. If you want to use a random number between 0 and 1, then that has to be divided by whatever is the largest number that can be stored. But these are integers, so you cannot divide them directly. So it has to be converted to float first. So numerator will be converted to float, and then denominator will also be converted to float first, and then the division will be carried out, and that is how you will get a random number between 0 and 1, uniformly distributed random number between 0 and 1. And then you set the precision as 3, so you would have 0.123. And this is the condition IRAN plus equal 1, so this is increment, right? So this is the index, and I must be using somewhere condition, yes, while. So this while loop generate about 100 random numbers. So this number is initialized to 0 initially, and then it continues up to 99. So IRAN ranging from 0 to 99, it will continue printing random numbers. So 100 random numbers uniformly distributed between 0 and 1. And you have this set precision, so 3 numbers, and this is left, so that is left justified. You can have right justified, you can have center, whatever is preferred. So you can actually do that. So for I is equal to whatever value of I, you can get this. So just simple code to play with these commands for format control. You can have more fun with format control. Just try out. Have a look at IO header file and you will get more information about what controls are available. I showed you how to look at the header files. Those will be available in the system area and those will be readable. You may not be able to modify the contents, but you should be able to read those files. So once you read those files, those will contain the declaration of different functions and that should be able to tell you what all features are available for manipulating the control input output fields. So that's it for today. Uh, Let us work on this for our next practical session.